Imagine a vast crimson expanse under a sky bruised with perpetual twilight, where the wind whispers secrets across dunes that have slumbered for eons. Now picture this: a six-wheeled sentinel, forged in the fires of human ingenuity, pauses amid jagged outcrops, its laser eyes piercing the veil of dust to reveal tiny, enigmatic spots. Leopard-like flecks in a rock billions of years old. These are no mere geological quirks. They pulse with the faint echo of possibility, a whisper from the dawn of time suggesting that life, in its most primordial form, might once have stirred on Mars. If true, this isn't just a discovery, it's a fracture in the cosmos, a revelation that could shatter our solitude and bind us to a shared cosmic lineage. But in the unforgiving arena of science, whispers must endure the storm of scrutiny. Have we finally glimpsed the hand of alien biology? Or is this another cruel mirage in the red desert? Strap in, because we're about to traverse the edge of the known universe, chasing shadows that could redefine everything. February 18th, 2021. The sky over Mars ignites with a brief, fiery ballet as NASA's Perseverance rover, affectionately dubbed Percy by its human handlers, plummets through the thin atmosphere, parachutes billowing like ancient sails, retro rockets roaring defiance against gravity's pull. It touches down in Jezero Crater, a 28-mile-wide scar on the planet's face, once a thriving lake fed by rivers carving deltas of silt and clay. Here, 3 billion years ago, water flowed freely, pooling in tranquil basins where sunlight danced on ripples and sediments settled like forgotten memories. Clay minerals, those silent architects of preservation, abound in this soil, compounds that trap organic whispers, shielding them from the ravages of time. Percy's mission is etched in steel and silicon, seeks signs of ancient microbial life, the invisible architects of Earth's own origins, and cache samples for a journey home. Jezero isn't chosen lightly. It's a time capsule, rich in perchlorates that Earth microbes devour in extremis, hinting at habitability in worlds both harsh and hidden. Fast forward to the sweltering Martian summer of July 2024. Percy, having traversed 18 miles of treacherous terrain, dodging boulders the size of houses, navigating sand traps that could swallow lesser machines, edges into the Neretva Vallis Channel. This ancient riverbed, a quarter-mile-wide gash etched by cataclysmic floods, spills into Jezero like a vein from the planet's watery youth. The rover's mass camera swivels, capturing the Bright Angel Formation, layered outcrops rising like petrified waves, their surfaces etched with the subtle striations of long-vanished currents. Then, amid the rust-hued anomaly, a rock, arrowhead-shaped and unyielding, christened Shayava Falls after a distant Earth waterfall that tumbles into the unknown. It's a mudstone relic, sedimentary layers whispering of deposition in still waters, now cracked and veined by epochs of thirst. Percy's arsenal awakens. The planetary instrument for X-ray lithochemistry, or PIXL, deploys its robotic arm like a surgeon's scalpel, mapping elemental signatures with X-ray precision down to micrometers. Nearby, Sherlock, the scanning habitable environments with Raman and luminescence for organics and chemicals, fires ultraviolet lasers, coaxing fluorescence from hidden organics, its Raman spectrometer dissecting molecular bonds like a cosmic detective. The verdict unfolds in data streams hurtling 140 million miles to Earth. Clay and silt dominate, exquisite preservers of microfossils on our planet. But deeper still, organics, carbon-based molecules, the alphabet of life, cluster in rings and spots. These leopard spots, mere 200 micrometers to a millimeter across, resemble poppy seeds in their dotted defiance. The inner halos mirror the rock's baseline chemistry, but the dark rims? Enriched with iron and phosphorus, hallmarks of localized reduction, where oxidized iron, 3, yields to ferrous iron, 2, releasing energy in a geochemical tango. Water's ghost haunts every scan. The rock's texture, fine-grained, compacted, screams submersion, a mudflat baked dry by solar winds. Organics entwined with iron reduction. On Earth, this triad births biosignatures, itched by microbes thriving without oxygen. Yet Mars demands doubt. Could heat from ancient volcanism have forged these features? Volcanic gases leaching sulfides into groundwater, migrating through fractures to cool sediments? No evidence surfaces, no hydrothermal vents scar the vicinity, no isotopic fingerprints of magmatic fury. Sulfate reduction via organics alone? Feasible, but sluggish below 150 to 200 degrees Celsius, demanding energy Mars' tepid past couldn't muster. Spectral analysis of surrounding strata confirms temperatures hovered near ambient, 20 to 50 degrees Celsius, too mild for abiotic alchemy. Acidity looms as another specter. Acidic waters dissolve iron and sulfate ions voraciously, priming chemical reductions sans biology. But then a counterstrike. Nearby, a fist-sized nodule of olivine gleams green under Percy's gaze. Olivine, the swift sentinel of pH, its silicate chains woven of magnesium and iron ions, electrostatically bound, shatter under hydrogen's assault in low pH realms. Orthosilicic acid and dissolved metals flood acidic solutions, eroding the mineral in weeks. Yet here it endures, intact, implying neutral waters, pH 6 to 8, a cradle for life, not a cauldron for dissolution. The acidic hypothesis crumbles, dust in the Martian breeze. Enter the minerals that steal the scene, vivianite and greigite, crystalline envoys from Earth's microbial underbelly. Vivianite, iron phosphate's pale blue-green avatar, crystallizes where geobacter kin respire iron oxides, exhaling ferrous waste that bonds with phosphates in wet sediments. Chemosynthesis fuels this ballet. No sunlight required, just the quiet harvest of geochemical gradients. Greigite, iron sulfide's magnetic kin, emerges from sulfate reducers, cleaving sulfur chains, yielding sulfides that snare iron in nodular embrace. On Earth, these duo grace peat bogs, river deltas, decaying organics, microbes, metabolic graffiti. In Chiava Falls, they manifest identically, vivianite veins threading the spots, greigite flecks dotting the rims, organics as carbonic accomplices. Skepticism sharpens its blade. Non-biological forges? Vivianite from abiotic precipitation in anoxic depths? Possible, but rare without life's nudge. Phosphorus mobility demands precise APH balances, fleeting on a dynamic Mars. Greigite some microbe? Lightning strikes or cosmic rays ionizing sulfates? Traces, yes, but not the concentrated halos Percy maps. The rover's supercam, zapping the rock with lasers to vaporize microdots for plasma spectroscopy, detects no extraterrestrial contaminants, no iridium spikes from impacts, no xenon anomalies from solar flares. The null hypothesis fractures, months of modeling from JPL's simulation chambers to ESA's geochemical labs, exhaust abiotic avenues. What's left? A biological echo, faint but insistent. Science thrives on falsification, not faith, a Paparian forge where ideas burn or bend. The Chayava team, over 1,000 minds from NASA, ESA, and global outposts, wielded Occam's razor with surgical grace. Null, abiotic origins. Test, thermal proxies via quartz crystallinity. Low, confirming cool deposition. Redox zoning via electron microprobe. Sharp boundaries, microbial scale. Organic integrity via pyrolysis, stable, untarnished by heat. Each strike chips away, leaving biology as the parsimonious survivor. Yet restraint reigns. We cannot rule out non-biological processes entirely, admits Katie Stack Morgan, Perseverance's project scientist, her voice steady amid the data deluge. Earth's biochemistry is our lens. Mars might wield a different palette, silicon-based, ammonia solvents, enigmas beyond our carbon chauvinism. NASA's caution echoes ghosts of glory's past. June 1996. Meteorite ALH 84001, ejected from Mars 15 million years ago, crashes into Antarctic ice. Under electron microscopes, nanoscale fossils, carbonate globules, magnetite chains, evoke bacterial blooms. President Clinton addresses the nation, the Rose Garden a pulpit for cosmic kinship. Today we celebrate not the completion, but the opening of a new chapter, he intones as stock markets waver and theologians scramble. But serpentinization, a water rock waltz in alkaline vents, unravels the tale by 2022, abiotic crystals mimicking life's filigree. False dawn. Rewind to 1976. Viking 1 and 2, NASA's twin landers, sprinkle radio-labeled nutrients on Martian regolith. Gas exchange experiments register spikes. Radioactive CO2 exhaled as if dormant microbes feast. Headlines scream, "Life on Mars." Ecstasy grips labs. Carl Sagan toasts the stars. Yet Phoenix's 2008 perch reveals perchlorets, Martian soil's oxidative scourge, mimicking biology in thermal chambers. Chemistry's cruel ventriloquy. These scars temper today's thrill. Chayava Falls, with its layered intrigue, demands repatriation. Percy's drill bites July 21, 2024, coring 2.4 inches of mudstone. Sapphire Canyon, sealed in titanium. A 33rd tube in a depot of 43, awaiting extraction. The Mars Sample Return, MSR Odyssey, looms, a tripartite epic of engineering audacity. Phase 1, done. Percy's cache is scattered like breadcrumbs across Jezro's floor. Phase 2, a sample retrieval lander touches down 2030s, birthing helicopters, Ingenuity's kin, but armored for autonomy, to snatch tubes, ferrying them to a Mars ascent vehicle, a slender rocket igniting in alien gravity. Phase 3, ESA's Earth Return Orbiter snags the payload in Martian orbit, hurtling it 33 million miles homeward, capsule scorching through our sky by 2033 or 2040, budgets willing. Cost $8 to $11 billion, a pittance against the infinite. Yet turmoil brews. 2024's Independent Review Board decries complexity, ballooning timelines. Redesign/mass may be from 450 kilograms to 350 kilograms, RTGs supplanting solar fragility. Industry beckons, SpaceX's Starship eyed for heavy lift, JAXA's precision for rendezvous. As of October 2025, NASA teeters, layoffs at JPL claim 550 souls. Fiscal year 2026 budgets loom under political crosshairs. The Decadal Survey, convened triennially by the National Academies, crowns MSR priority numero uno, thrice over. Chayava's siren call amplifies the plea. For $11 billion, we ransom truth from the red void. Should Sapphire Canyon breach Earth's embrace? Anticipated 2033 in optimistic arcs, 2040 in shadowed ones. Labs worldwide ignite. Chirality first, amino acids handedness, life's asymmetric preference. Earth's biology favors L forms, a 50-50 abiotic split skewed by evolution's whim. Gas chromatography mass spectrometry dissects the core, seeking enantiomeric excess, D or L dominance, screaming selection, not chance. Carbon isotopes follow. Life's thrift hoards 12C over 13C, fractionation etching ratios in biomass. Accelerator mass spectrometry quantifies, hunting biogenic bias amid carbonate veils. Beyond, pyrolysis gas chromatography for macromolecular fossils, synchrotron X-rays for nanotextures, electron paramagnetic resonance for organic spins. A gauntlet of 100-plus protocols cross-verified by blind interlabs to pierce the veil. Binary thinking, life or not, betrays nuance. NASA's Confidence of Life Detection, CoLD scale, forged in 2018's astrobiological crucible, ladders certainty from ambiguity to apotheosis. Level 1, disequilibrium, a whisper of anomaly. Level 2, anomaly contextualized, habitability affirmed. Level 3, biosignature candidate, multiple lines converging. Chayava perches here, organics, minerals, redox in aqueous youth, per September 2025's Nature paper. Level 4, independent replication, Rover's suite corroborated. Level 5, unambiguous signal, abiotic mimics slain. Level 6, diverse confirmatory datasets, chirality, isotopes, morphology. Level 7, repeated multi-site validations, a symphony of evidence. Cold demands sensitivity, sterility, repeatability, features detectable, preserved, reliable, life-compatible, biology as last resort. No hype ascends unchecked, each rung a gauntlet. Chayava teeters at 3, tantalizing, but earthbound trials could vault it to 5, or plummet it to prosaic chemistry. Even in defeat, victory gleams. Mars, bereft of plate tectonics, stands as stasis incarnate. No subduction recycling crust, no Himalayas crumpling continents. Its face, frozen 4 billion years, hoards Hadean echoes, Earth pulverized in fiery churn. Jezero's mudstones mirror Archean shallows, when our world birthed stromatolites in sunlit pools. Chayava, young at 3.5 billion years, post-Noachian, amid waning warmth, probes habitability's tale. Olevine's persistence hints neutral lakes persisting late. Vivianite's veins suggest persistent anoxia. Abiotic or not, it unveils geochemical crucibles, life's potential nurseries. Mars's Rosetta, decoding abiogenesis, the spark from void to vitality. Dare we dream bolder? Suppose Sapphire confirms microbial mats undulating in Jazero's shallows, chemotrophs oxidizing iron in lightless oases. Habitability endures eons, outlasting Venus's runaway, preceding Europa's ice. Panspermia ignites. Did Mars seed Earth via lithic hitchhikers, or vice versa, meteor maelstroms faring primordial soups? Independent origins? 2 Genesis events in one system. FL and Drake's equations surging from epsilon to unity. Habitable worlds birthing life as norm. N communicative civilizations, cascades, from solitary to symphony, our galaxy teeming. 0, 1 infinity, we eclipse 0. 1 isolates, 2 heralds boundless. Life, not freak, but fabric, woven across Enceladus plumes, Titan's hazes, Trappist one's worlds. Yet infinity terrifies and unites. Proof of neighbors humbles hubris, our blue marble a speck in biophilic blaze. Astrobiology's 0-1 law posits rarity or ubiquity. Mars tips the scale. If kin were not alone, cosmic siblings in stasis. If autochthonous, biogenesis banal, universe a verdant web. Either rends isolation, fostering stewardship. Earth's wounds heal in stellar solidarity. No longer titans, but threads in tapestry, urging equity, exploration, empathy. The weight settles. Chayava falls, a fulcrum. MSR's fate hinges on resolve. Budgets battle bureaucracy, but discovery's fire forges paths. As perseverance climbs Jezero's rim, scouting ascent for human heirs, we stand at precipice. Will Sapphire return, unveiling kin or catalyst? The red wanderer holds her breath. What say you? Mirage or milestone? Dive into the comments, share your cosmic convictions, subscribe for the chase's every turn. The stars await our verdict. Information updated as of October 23rd, 2025.